Andrew Radford. Oh, hello, fellow astronomers. How are you doing today? Today, I'm going to talking to you guys about dark matter. So, how exactly do we know that dark matter exists? Well, Johannes Kepler figured out that the farther a planet is from the sun, the slower it'll orbit. Using that knowledge and also the Doppler shift, Rubin was able to discover that the farther from the center you went, the faster the clouds are moving for a galaxy. Kind of the opposite. Rubin discovered that there must be 5 or 6 times the amount of seeable matter. Something was contributing to the gravity besides star, dust, and gas, and that is what is known as dark matter. So, what are some ways that we can detect dark matter? Well, one of those is gravitational cleansing. Einstein once said, "Space is not just emptiness between stars." So, not to read into that literal, but gravity has a force and can bend light. So, if we look at this, I have a fabric of space right here. If I roll this light right here across the fabric of space, it'll travel in a fairly straight line. But if I use this planet or some kind of mass lands in the middle and I roll the light, it'll now bend. So we call this gravitational cleansing. So why is this knowledge important? Why would we need to know that? We use this information for the bullet cluster. So the bullet cluster was 2 galaxies colliding, and everything passes through except for the gases, which when they collide with each other, they emitted bright lights and everything, and so they emitted X-rays. And we could detect those X-rays, and we were able to see, we were able to calculate the mass using the distorted background images, and we can measure the distortion and make a map of the mass. And when we look at the picture after, you can tell that something that we can't see, a dark matter, is present there. So, what is dark matter? What exactly is it? We don't actually know what dark matter is. Some possible options for dark matter is the machos, neutron stars, black holes, brown dwarfs, or also the WIMPs, like subatomic particles, axions, which they have mass and they emit very little light, so they could be something that affects the gravitational cleansing, and it could be a possible option for dark matter. So, although we don't know everything about dark matter, it's had great effects on the universe and even plays a part in the Big Bang. I hope you guys enjoyed my little lecture about dark matter, and hopefully you learned something new. This video was produced by Andrew Radford. Thank you.